So now that we know how to add and subtract rational expressions with the same denominator, let's talk about how to do that when our denominators are different. And again, we'll start by looking at what we do with regular old fractions. If I have 33 over 40 minus 25 over 36, I can't subtract them right away because the denominators are different. So I have to find the least common denominator. Technically, I could find any common denominator, but if I get the least common denominator, then I'll have little to no simplifying to do at the end. Well, how am I going to find that? Well, remember, to do that, one option is to use a factor tree. I can take 40 and factor that in any way I want. I'll choose 5 times 8. To factor 5, I can't because it's prime. To factor 8, it's 2 times 4. 2 is prime. 4 is 2 times 2. And again, the 2's are prime. So 40 can be expressed in factored form as 2 to the 3rd power, because I've got 3 2's, times 5. I list all the different factors that show up, raised to the appropriate exponent. Here, this is exponent 1, because there's only one of those 5's. For 36, I can do the same sort of thing. 36 is 6 times 6. 6 is 2 times 3. This 6 is also 2 times 3. And 2 and 3 are both prime, so I'm done. I've got 2 2's and 2 3's, so 2 squared times 3 squared. Okay? So this is how my denominators factor. How do I find the least common denominator? Well, I need a number that's big enough that both of these can fit into it. They don't have to both fit into it at the same time, but they just both have to fit into it. Well, this one has 2's and a 5, so I know my least common denominator is going to need 2's and a 5. We'll talk about how many in a second. This one has 2's and 3's, so I know my least common denominator is going to have 2's and 3's. Well, I already have 2's, so I'll need 3's. So I need 2's, 5's, and 3's. But how many of each do I need? Well, I need at least 3 2's to fit this number into it. And I need at least 2 2's to fit this number into it. But I don't need 5 2's because I don't need to fit both of these into it at the same time. I only need to fit in one at a time. So as long as I get a large enough number to fit each one, then I'm good. So if I need 3 of them here and 2 of them here, then I'll be good if I have 3 2's. So then this guy will be happy, he fits in. And this guy will be happy too, because if I have 3 2's, then I can definitely fit in 2 2's. All right? And I do the same thing with the other factors. This guy needs 1 5 at least, and this guy doesn't need any 5, so I need at least 1 5. And the 3's, this guy doesn't need any 3's. This guy needs at least 2 3's. So I got to have at least 2 3's. So what I've done is, after factoring it, found each different factor that showed up and used the highest exponent on each one of those factors, because that's what's going to be necessary to get a common denominator. I could have used 5 for my exponent on 2. That will give me a common denominator, but not the least common denominator. And I will have some simplifying to do at the end if I put those extra 2's in. All right? So this is my least common denominator. And if you work that out, that's 8 times 5 times 9, which comes out to 360. Okay? So what we're going to do to finish this is we're going to convert each of these fractions into an equivalent fraction whose denominator is 360. Oh, and I just erased that. This was, so what was this? This is 33 over 2 to the third power times 5, if I write it in factored form. And this is 25 over 2 squared times 3 squared. So how am I going to write these fractions so that their denominator is this? Well, I need to find out what's missing and put it in. So here I have 3 2's and a 5. Here's what I need. I need 3 2's and a 5, and also 2 3's. So what's missing from here to turn it into the least common denominator is that 3 squared. So I'm going to, and I'll change colors so that this doesn't get confused, multiply by 3 squared in the denominator to get that common denominator. But in order to make this an equivalent fraction, I've got to do the same thing in the numerator. Okay? Now, this one, same idea. I have 2 squared. I need 2 cubed. I have 2 2's. I need 3 2's. So I need one more 2, which means I need it in the top and the bottom to keep the value the same. I have 3 squared. This is covered then. But I don't have any 5, so in addition to this 2, I'm going to need this 5 also. Okay? And so now I can multiply these out in the numerator so that I can then subtract. Well, I know my denominator is 360 for both. And in my numerator, I've got 33 times 9, okay, which is going to be 297. Here I have 25 times 10, which is 250. So 297 over 360 is the same as 33 over 40. And 250 over 360 is the same as 25 over 36. But now, even though they're the same, I couldn't subtract these, I can subtract these because the denominators are the same as each other. And I do that by subtracting the numerators. 297 minus 250 is 47. Again, just as before, it's over my common denominator. Since we're going to have to find the least common denominator to do these sorts of questions, let's practice a little bit by finding some least common denominators. If my two denominators are 10a to the third b to the fifth and 15a squared b to the sixth, what is the least common denominator going to be? Well, again, I can find it by factoring my two denominators. And the process I used before was I write each factor that appears and I put the appropriate exponent on it, the largest one in either denominator. So 10 factors as 2 times 5. 15 factors as 3 times 5. So I've got 2 times 5 times a to the third times b to the fifth, and 3 times 5 times a squared times b to the sixth. So all the different factors that show up are 2, 5, 3, those are all the numbers, and for the variables, a and b. Over here I have a and b also. And the exponents that go on them, 2 has an exponent 1, There are no 2's here, so just a 1. 5 and 5, in both cases the exponent is 1. And here the 3 has exponent 1. There are no 3's over here. So all those are to the power 1. But what about a and b? Here a is to the third power, here it's to the second power. In order to accommodate both, I need a to the third power. Remember, I don't have to accommodate both at once. Just doing them individually is enough. So if I have a to the third, then this one is satisfied. And this one separately is satisfied. Because I only need a squared, and I have a to the third. I have more than what I need to cover this one. And for b, I have b to the fifth power and b to the sixth power. To satisfy either, I need b to the sixth power, because I need at least 6 to cover this one. And that will also cover this one that needs at least 5. So there's my least common denominator. And I'll go ahead and, like these, multiply the coefficients together. 2 times 5 times 3 is 30. So I have 30. A to the third power, b to the sixth power will be my least common denominator. I would then, if this were an addition or subtraction with these denominators, I would convert those rational expressions to have this denominator and proceed to add or subtract numerators. And we'll look at examples of those in a couple minutes. Now, 2x and x plus 2 are my denominators. Well, what's my common denominator? These are really already factored. There's nothing more I can do. So, what factors show up? Here I have a 2, and here I have an x. What do I get over here? Do I get an x and a 2, so my LCD is 2x? No. And the reason is because these are added. X and 2 are not factors. To be factors, they have to be multiplied. So that means when I put them together like this, x plus 2, the entire thing is one factor. So my least common denominator is going to be 2x times x plus 2. Or if I want to multiply that out, I could write 2x squared plus 4x. Generally, it's going to be easier to work with it in factored form for us. So now you have to start being able to identify polynomial factors when building your least common denominator. Let's see another one here. If these are my two denominators, to identify common factors, again, like all the other examples, I have to factor. So to factor this, I can do a greatest common factor of y squared. Y plus 4 is the other factor. Here, there's a y in common. Y squared plus 3y minus 4 is the other factor. But I can factor this further. Y squared plus 3y minus 4 factors as y minus 1 times y plus 4. So what factors show up? Well, I've got y's. I've got y plus 4's. Y is already covered. I've got y minus 1. And y plus 4 is already covered. Now how many of each? Or in other words, what's the exponent? Y has 2 or 1. The greater is 2. Y plus 4 has 1 or 1. The greater is 1. And y minus 1 has exponent 1. And it doesn't even show up here, so 1 covers it. There's my least common denominator for that one.